Welcome to Careless Coder. Today part 2 of Simon Ziggy Says implementation on the Raspberry Pi Pico. Motherfucker! So in the last episode we set up the hardware for our Simon Ziggy Says game and we tested out that the LEDs, the outputs, are working. So now we're going to implement our lizard people overlord's brain. Because we all know that we are ruled by lizard people.
Lizard people?
Yep, lizard people.
Lizard.
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 Better.
And we have to blindly follow and obey the lizard people. What, didn't you guys watch V in the 80s? Come on! So let's implement Ziggy's brain into the Raspberry Pi Pico. Or basically it's just an array that we're going to play back. Let's have some fun. So last time we ended in this situation where we had the Knight Rider scanner up and down of the 4 LEDs that we have connected to the Pi Pico. And let's now build this up a bit further so that we can actually have Simon generate a random sequence and play that sequence one step at a time and repeating that whole sequence for every new step. So last time we left off here, that we had a Knight Rider scanner with the 4 LEDs that we have connected here. So it scans up and down. So let's build upon that and we gradually build it to a Simon game. Insert your dictator here game that you blindly follow like all other sheeples. So now we're going to just generate a random sequence of 30 steps and we will let Simon just replay those for a period of the number of steps, and the number of steps is actually dependent on your level. So later on we will have the 4 buttons, so we press for example this button and then we will play 10 steps. If we press this button we play 15 steps, this button 20 steps and this the whole 30. And gradually it will also get faster. So let's create a array that holds the values 0 to 3, 0, 1, 2, 3. We can use basic arithmetic just to deduce the output pins and the input pins. Talking about input pins, let's first set those up. So basically we start at pin 6 till 10. That is how this works. It's till 10 because 10 has the piezo. So then we have all the switches set. So 6 till 10. And it's an input. And we set pull to up, and then we have for pull-ups up, ready. Okay, let's clean this up and let's start with a nice basic beginning of a game loop. Let's do a reset game, and that will take in that sequence by reference that we're going to define here. So let's make a sequence for sequence, which is, let's create a constant with the number of steps. Hey, why is my home not working? There we go. I really have issues with my keyboard. There's something really weird happening on. Alright, so let's create a max sequence size 31. We actually need 30, but in case you're off by 1 with embedded systems, well, that could be disastrous, especially in this case because we're actually going to write to it. So if I'm not pressed for memory, I just calculate that in. I know we're good, but that is the reason why I do it a bit bigger. So we said we can now have the max size, and it is of type U8. Now, of course, we're going to set in what we agreed on 0, 1, 2, 3 for the moves. But we're going to use the ASCON randomizer that is part of the RP2040, which actually has a function called bytes, which just generates U8 bytes on an array. So that is really easy. And then we just chop off the top, and for memory size it doesn't really matter. Alright, yeah, so reset sequence. Let's build that. Let's do that here. fn reset game. So we put in the sequence, which is of max size. This is so stupid. If you fill it in, why not move that cursor over? Come on. And we return void. And we're going to use ASCON. I keep thinking of ascot. Like, James, I'm wearing my ascot. James, would you get rid of those suspicious stains on my duvet on my bed? Oh, I will be delighted, sir. Anyways, yeah, Dirty Mind, enjoy you forever. So ASCON, we use the rend. Well, let's include that because we have not included it. Const rend equals rp2040.rend. Right, rend .ascon.init. Right, and now we can make a variable random number generator equals ascon.random random. What the hell? Random. Thank you. Okay, and then we can use that magical function that they have, random bytes sequence. And well, that goes from 0 till, well, Zig can figure out the size. It's after all not C. It's a lot better than C. But now we have a sequence with random numbers with values 0 to 255. And we agreed we want 0, 1, 2, 3. So we need to basically mask off the bottom two nibbles. So do a logical AND with 3. So for 0 max size, capture the I. That is something that I always forget, by the way, here. And let's do a sequence. I becomes what is already in there on location I. Ended masked off by 3. So now we have a nice little sequence that contains of 31 characters, or actually 32, a little bit of a buffer over dimension just to be safe. That has the value 0 to 3 in them. That is cool. All right. Now we also need to, of course, be able to have Simon play the move. So let's create a play move function. And the moves in the sequence, so what is on a cell here, we call it a move. Let's call that, that's a U8, we know that. And we also need to decrement the waiting time. So let's pass in a speed as well, and let's make that U32. After all, it's a 32-bit CPU, and we actually have more than 300, in this case 350, 300, so more than 255. So let's keep it simple. Right, and then let's calculate the pin, which is again a U5 because the GPO num takes a U5, which again is the truncate of the move. And in order to get to the pin, to show the move, we basically need to add the starting pin number, so 2. So if we add 2, then we're set to get the pin. And this is why I love using the low-level stuff, because I can just do basic arithmetic. No need to do name matching with switch statements or if they blah. Just do your calculation. Okay, so we can now turn it on. gpio.num pin dot put, and we put it to 1, and then we do the time sleep with this many milliseconds. Sleep milliseconds, speed. Actually, speed is a bit of a misnomer. It's slowdown, right? But And now we need to turn it off with that same duration. Okay. So now Simon can basically show a move. So if you put in 0, 300 milliseconds, it will toggle the LED 2, in this case, pin 2, for 300 milliseconds. If you put in 3, it will actually toggle pin 3. Now you could add some card clauses here that if it is more than 3 that we should not do it. But since it's a private function anyways, and we know what we're doing, we're perfectly fine. Last famous words. Okay, so let's make Simon play. So Simon, which takes in a sequence of max positions, U8. And of course we need to know the current step that we're in, because Simon will, if step is 1, it will randomly select a pin, say for example red. If it is step 2, it will actually need to show step 1, the red pin, and the step 2, for example green, so red green. If the third step is yellow, then it should show red, green, yellow. So the step is important. And that will actually come from a for loop. So let's make it a U size. That is how for loops capture works. And of course the speed that we just did for the play move. Okay, and it's a void. Alright, and then we're just going to loop. And we need to loop, of course, the number of steps plus 1, because we also want to show the next step and the previous steps. And we need to capture this. I always forget that with Zig, to capture the eye. Right, and then we can just call play move that we just created. Nice and clean. And we just get the move from the sequence and we pass the speed. So you see, I really like to write small functions that just do one thing, which makes it so much easier to debug and find errors, but also to reason through your code. Like, okay, this does this, this does that. Right? So I think that we can actually create a bit of a hacky game loop. Later on we will refactor this. Let's have Simon show a maximum of 5 steps. We don't do any user input, that comes later. So let's call Simon. Let's pass in that sequence by reference. And what else do we need? We need the step, of course. And then, of course, I need to capture it. Just like I said, I always forget that. And speed, let's put it to 300 milliseconds, which will be the starting speed. And let's have a nice little delay of 500 milliseconds between every go, half a second. At least then we can see something, right? And do we need something else? Reset, I think we got there. So let's do a Zig build and see what happens. And of course, I missed something, a void, trust me. Yeah. There are a couple of things that I always forget. That is capturing in an if statement and the return. Sequence U8 must be initialized. Yeah. Let's, where was it? Here. It is undefined until we do the reset game. And every time that the reset game is done, so this will become our game loop in the next episode. We actually create a function game loop that loops through it. So when the game is done, it will reset the game, so it will generate a new sequence. So let's build this. Still an error. Parameter type declared here. Reset. Oh, reset game. I forgot a star. Pointer. Pointer, yes. Did I do it again? 42. Yeah, I forgot it again. Pointer. And there it goes. Okay. So let's go to the Zig out. And under bin, let's do the elf to UFS2, UF2. Simon to Simon dot UF2. Let's do the boot cell trick. I really like the fact that I have that switch on my USB hub, because pulling in and pulling out that USB stick or connector really wears your port. Alright, so there we go. We should actually be mounted for our CP. There we go. Yeah. Yes. Five. 1, 2, 3. So let's do a little sleep here, so we can actually see it a bit better, because now they tend to bleed over. MS 1000, 1200, also good. Let's build it again. Okay, let's copy this. Yeah, 5 steps and we get a new sequence. Yes. So we have now Simon being able to generate random steps and actually feed them back, play them. So there you have it. Ziggy is now spouting out his demands that we need to blindly follow. So that is cool. So in the next episode we can actually implement the user input. And this is how we build up the whole game. So yeah, we're getting there. And it's a lot of fun and it's really easy. Zig is just a lovely, lovely language. I adore Zig. I like Rust, but I adore Zig. So I hope you learned something and see you in part 3. This is how Americans do it, right? Us Europeans do it like this. So, laters!